Hey everyone! Welcome back to. Today we're exploring a topic that's at the crossroads of technology and innovation: blockchain versus traditional databases. You've probably heard of blockchain, especially with the rise of cryptocurrencies. But what exactly is it, and how does it compare to the databases we've been using for years? Is it a passing trend, or is it here to stay? In this video, we'll break down the key differences between blockchain and traditional databases, exploring their strengths, limitations, and ideal use cases. By the end, you'll have a clear understanding of these powerful technologies and how they impact our digital world. Let's dive in. Let's start with the basics. Imagine a traditional database like a big organized filing cabinet. It stores all sorts of information in a structured way, making it easy to find what you need. Think of customer data in an e-commerce store, financial records in a bank, or student information in a school system. These databases are the backbone of countless applications we use every day. Now picture blockchain not as a single filing cabinet, but as a shared, transparent ledger distributed across multiple computers. It's like having copies of that important information spread across a network, ensuring that no one person or entity has complete control. Traditional databases, like those managed by tech giants like Google or Amazon, are centralized. This means a single entity controls the data, its security, and access. While this centralized approach can be efficient, it also creates vulnerabilities. So keep this distinction in mind as we delve deeper into the world of blockchain and traditional databases. Centralization versus decentralization is a core distinction. Centralized data is controlled by one authority. This can be efficient, but risky. A single point of failure compromises all data. Blockchain decentralizes data across nodes. Each node verifies transactions, enhancing security. This shift fosters a secure, equitable digital landscape. Let's move on to another crucial difference: how data is structured and stored. Imagine a traditional database as a giant spreadsheet. Data is neatly organized in rows and columns, forming tables that relate to each other. You can easily update, delete, or modify this data as needed. This flexibility is essential for many applications, allowing businesses to adapt to changing information and user needs. Blockchain, however, takes a different approach. Instead of a spreadsheet, picture a chain of blocks, where each block contains a set of transactions. Once a block is added to the chain, it's linked to the previous block using cryptography, creating a chronological and tamper-proof record. This structure makes blockchain data immutable. Once a transaction is recorded and added to the blockchain, it cannot be altered or deleted. This permanence might seem limiting at first, but it's a game changer when it comes to trust and transparency. Think about financial transactions. With traditional systems, there's always a risk of fraud or manipulation. Blockchain eliminates this risk by creating an unalterable record of every transaction. Chapter 4: Security and Trust. In today's digital age, security is paramount. We entrust our personal information, financial data, and even our identities to online platforms. So how do blockchain and traditional databases stack up when it comes to safeguarding our valuable data? Traditional databases rely on centralized security measures. The central authority invests heavily in firewalls, access controls, and encryption to protect the data they store. While these measures are generally effective, they are not foolproof. A determined hacker, if they manage to breach the central system, can potentially gain access to all the data stored within. Blockchain, on the other hand, takes a fundamentally different approach to security. Instead of relying on a single point of protection, it distributes security across the entire network. Each transaction added to the blockchain is verified and validated by multiple nodes using complex cryptographic algorithms. This decentralized security model makes blockchain incredibly difficult to compromise. This inherent security is one of the key reasons why blockchain is considered a game changer for industries dealing with sensitive data. This level of transparency fosters trust among users, as everyone has access to the same information. Chapter 5: Performance and Scalability. While blockchain excels in security and transparency, it's not without its limitations. One area where traditional databases currently have the upper hand is performance and scalability. Traditional databases are designed for speed and efficiency. They can process thousands, even millions of transactions per second, making them ideal for applications that require real-time data processing, such as online banking or e-commerce. These centralized systems are optimized for handling large volumes of data and can easily scale to accommodate growing user bases. Blockchain, with its decentralized nature, faces challenges in terms of speed and scalability. Every transaction added to the blockchain needs to be verified and validated by multiple nodes across the network. This consensus mechanism, while crucial for security, introduces latency. Transactions on a blockchain can take seconds, minutes, or even longer to process, depending on the network traffic and the complexity of the transaction. So, while blockchain might not be the best fit for every application, its strengths in security, transparency, and trust make it a compelling alternative for specific use cases. Chapter 6. Use Cases. Let's explore where blockchain and traditional databases excel. Traditional databases power online banking, e-commerce, and CRM systems. Blockchain excels in security, transparency, and trust. Key use cases include cryptocurrencies, supply chain management, and digital identity. Chapter 7. Summary of Differences. Let's recap the key differences between blockchain and traditional databases. 1. Centralization versus decentralization. Traditional databases are centralized, with a single authority controlling the data. Blockchain, on the other hand, is decentralized, distributing data across a network of nodes. This fundamental difference has significant implications for security, transparency, and trust. 2. Data immutability. Data stored in a traditional database can be modified or deleted as needed. Blockchain data, once recorded, is immutable and cannot be altered or erased. This permanence ensures data integrity and fosters trust but can make correcting errors challenging. 3. Security. Traditional databases rely on centralized security measures such as firewalls and access controls to protect data. Blockchain, with its decentralized nature and cryptographic algorithms, offers a higher level of security, making it extremely difficult to compromise. That's all for today's video. I hope this breakdown of blockchain versus traditional databases was helpful. We've covered a lot of ground, from the fundamental differences in their structure and security to their ideal use cases. If you enjoyed this deep dive into the world of blockchain and databases, please like, share, and subscribe to my channel, Learn with CA Neha Agrawal. Don't forget to hit that notification bell to stay updated on the latest in tech and finance. Now, I'd love to hear from you. What's your take? Do you think blockchain will eventually replace traditional databases? Or will they coexist, each serving specific purposes? Let me know in the comments below. Until next time, stay curious and keep learning. Bye!